Hello everyone, myself Patil AS from SGM College, Karad. In a previous lecture, we completed the solubility as well as factors affecting on solubility. In this lecture, we start the new point, that means vapor pressure of a solution of a liquid in a liquid and the Raoult's law. Vapor pressure of a solution of liquid in liquid. We see now vapor pressure of a solution. First we understand what is mean the vapor. How the vapor will be formed. Vapors कसे तयार होतात किंवा vapor म्हणजे काय? तर vapor liquid पासून create होतात. When we apply a heat of that liquid, then that liquid convert into the vapor. काय केले आपण त्याला heat दिली. That liquid is converted into the vapors. These are the vapors. Conversion of liquid into the vapor is nothing but our evaporation process. And the evaporation rate increases, vapor pressure goes on increase. आता आधी पहिल्यांदा बघूया वेपर प्रेशर म्हणजे काय, वेपर्स म्हणजे काय बघितलं, इव्हॅपोरेशन म्हणजे काय बघितलं. आता वेपर प्रेशर म्हणजे या कंटेनरला आपण हीट देतोय, हे वेपर्स आहेत ते बाहेर जातात, these goes out, but when we apply a lid on that, त्याच्यावरती आपण एक झाकण क्लोज कंटेनर केलं. Now see what happens. Vapors are produced because we continue giving heat. Heat द्यायला start आहे. Now when that vapors goes up and contact with that lid. आता हे वेपर्स या लीड पर्यंत जाणार आहे. हा कंटेनर क्लोज आहे आणि त्या लीड वर गेला, ते बाहेर जाऊ शकणार नाहीये. They goes reverse back. परत येणार आहे. And the force will be generated by the vapor pressure on the surface of that liquid. त्या लिक्विडच्या सरफेस वरती एक प्रकारे प्रेशर क्रिएट होणार आहे. त्या प्रेशरला आपण काय म्हणणार आहे, वेपर प्रेशर. Vapor pressure of the liquid. Now we see the vapor pressure is present on the surface of the liquid. Surface वरतीच का vapor pressure create झालं? Vapor pressure सगळ्या liquid वरती create व्हायला पाहिजे होतं. कशावर झाले? फक्त surface वरती. Why? See here. A ची particles घेतले तर आपण A substance घेतलाय. हा A चा एक बल्क मध्ये असलेला मोलेक्यूल आहे. That molecule have a force on all the sides of that. सगळ्या बाजूने त्याच्यावरती फोर्स एक्झर्ट होणार आहे. तो फोर्स कसला असणार तर बॅलन्स्ड फोर्स असणार. प्रत्येकाचा फोर्स ऑफ अट्रॅक्शन सेम असणार आहे, कारण त्याच्या सभोवताली काय पार्टिकल्स, अजून वेगवेगळे एजेस पार्टिकल्स आहेत, ते एकमेकांवरती फोर्स अप्लाय करतात. बॅलन्स्ड फोर्स. container लिक्विड ए घेणार आहे. लिक्विड आहे ए सबस्टन्स आपण लिक्विड घेतला. दुसऱ्या कंटेनर मध्ये बी सबस्टन्स लिक्विड घेतला. Both containers are closed.
In our textbook, here we are taking A and B, but in our textbook A1 and A2, these two volatile solutions are taken.
Now see, the vapor pressure is present on the surface of that A. त्याच्यावरती pressure आहे. It is denoted by P. Denoted by P. A liquid है, therefore we write PA. No other substance or no other impurity present into that. It is a pure substance. Therefore we write a not on a upper part of that P. P वरती आपण not. It is the pressure किंवा vapor pressure म्हणूया. Vapor pressure of pure liquid A. Similar to that, P not B is the vapor pressure of pure liquid B. D liquid चा vapor pressure आहे. Pure substance आपण घेतलेला आहे. Therefore P not B. Now we take a mixture of that. म्हणजे आपल्याला काय घ्यायचंय? सोल्युशन घ्यायचंय A आणि B. It is also taking in a closed container. Both particles A and B are present on the surface. A, B. A and B दोन्हीचे पण particles वर असणार आहेत. A सुद्धा प्रेशर एक्सर्ट करणार आहे. A वरती सुद्धा B वरती सुद्धा प्रत्येकाचं वेपर प्रेशर एक्सर्ट होत असणार आहे. It is solution of liquid A and liquid B. Liquid A and B चं आपण एकत्र सोल्युशन घेतलं. याच्यावरती सुद्धा काहीतरी प्रेशर क्रिएट होत असणार आहे. That is pressure. Now this pressure is written according to Dalton's law. Dalton's law काय सांगतो? तर एखाद्या सोल्युशन वरती असणारं प्रेशर हे त्याच्या पार्शियल प्रेशरच्या समेशन इतकं आहे. पार्शियल प्रेशर. इथं आपण प्युअर सबस्टन्स घेतलाय का? No. Therefore we write as a partial pressure. P, the pressure of whole solution, we write as a T. That means total pressure. Total pressure. We write total pressure of solution is equal to partial pressure of liquid A plus partial pressure of liquid B. Liquid A आणि B चं summation घेतले. It is denoted by P, total pressure. Therefore we write PT is equal to, see, the partial pressure is by P of a liquid A, that means PA, plus partial pressure P of a liquid B. According to Dalton's law, we have a equation. This equation PT is equal to PA plus P.
In our textbook, here the total pressure of that solution is as a PT is equal to P1 plus P2. That means here for our understanding we take liquid A and liquid B, but in our textbook there is a P1 and a P2 for solution, volatile solution A1 and A2.
But there is a relation between that partial pressure as well as the vapor pressure. Vapor pressure आणि partial pressure त्याच्यामध्ये सुद्धा काहीतरी रिलेशन आहे. That relation is given by the scientist Raoult. Raoult's law. What is the Raoult's law? The partial pressure, partial vapor pressure of the solution is equal to the vapor pressure of a pure liquid. Vapor pressure of a pure liquid multiplied by its mole fraction. काय statement आहे Raoult's law चं? The partial vapor pressure of a solution of a volatile components are equal to the vapor pressure of the pure liquid multiplied by mole fraction. Now PA be the partial vapor pressure of solution component A is equal to the P naught A means vapor pressure of a pure liquid A into X A mole fraction of a liquid A. Similar to that we write PB is equal to P naught B into XB, where XA is the mole fraction of a liquid A and XB is the mole fraction of a liquid B.
For our understanding we take as A and B, but in our textbook here P1 is equal to P01 into X1, while for a second for a B in our textbook P2 is equal to P02 into X2. According to Raoult's law, the partial vapor pressure of an volatile component of a solution is equal to the vapor pressure of a pure component multiplied by its mole fraction in the solution. Now, from this video, we understand how the vapor pressure will be created on the surface of that liquid. When we start to give a heat, that particles of water are converted into the vapors, and when that vapors reach at that place, they can't goes out, therefore they again reverse back and they apply a pressure on the surface of this liquid. It is an example of vapor pressure, how the vapor pressure will be created. Now the equation for the Raoult's law we see here, solution containing solvent and a solute. From our textbook, the solvent and a solute, that means solution of two volatile component A1 and A2. The P1 and P2 are their partial vapor pressures, and X1 and X2 are the mole fractions of a volatile component A1 and A2. According to Raoult's law, the partial vapor pressure of a A1 is equal to X1 into P01, and a P2 means partial vapor pressure of a A2 is X2 P02. That P1, P01 and a P02 are the vapor pressure of a pure liquid of A1 and A2. According to Dalton's law, the partial pressure, total pressure, that means the pressure on that solution is equal to partial vapor pressure of the liquid A1 and a partial vapor pressure of the liquid A2. That means P is equal to P1 plus P2. From the equation number 1, we write X1 P01 plus X2 P02. From the equation, that means from the mole fraction, we know that the x1 plus x2 is equal to 1. If we write the x2 on the right side, the equation becomes x1 is equal to 1 minus x2. If we put the value of these into the equation number 2, that means put the value of x1 as 1 minus x2, we get p is equal to p naught 1 into bracket 1 minus x2 plus x2 p1 p naught 2. If we multiply p naught 1 to hold this bracket, we get p naught 1 minus p naught 1 x2 plus as it is p naught 2 x2. From these two, if we take common x2 outside, then we have an equation that is p naught 2 minus p naught 1 into x2 plus p naught 1. This is the equation for a Rolle's law. From that, if we draw the graph of a mole fraction against the vapor pressure, the values of a mole fraction, see here, if we write the value of x1 as a 1, how it will be possible? We know that x1 plus x2 is equal to 1. If we put the value of x1 as a 1, then x2 becomes 0. And if we write the value of x1 as 0, then x2 becomes 1. That means mole fraction of x2, we are taking a graph of a mole fraction of x2. The mole fraction goes on increases from left to right. Now the P naught 1 be the pressure of our A1 solution, and a P naught 2 is the pure vapor pressure of a pure liquid A2. The value of P naught 1 is as below as compared to P naught B. Why it will be happen? It is depend upon which compound is a more volatile. It have a high vapor pressure, while which is a less volatile, it have a less vapor pressure. If we join the P naught 1, then the P1 we have this line, and a P naught 2, then a P2, and if we join P naught 1 and a P2, we get a graph like a straight line graph. It is our PT is equal to P1 plus P2. The remaining part from this lecture is a composition of a vapor phase. The composition of a vapor phase in equilibrium with the solution can be determined by a Dalton's law of a partial pressure. That means if we take the x1 and a y1, x1 and x2 as y1 and a y2, then that y1 and y2 are the mole fraction of a two component having component in the vapors. Then we write the value of P1 is equal to y1 P and P2 is equal to y2 P, where P1 and P2 are the partial pressures of a two component in the vapor, and P be the total vapor pressure. Thank you.